Welcome all. So, this is a protocol stack overview, which is a continuation of architecture. And in this protocol stack view, the main ideas we are going to discuss is MQTT, CoAP, AMQP, HTTP, and DDS. So here all these concepts gives with one finest connectivity, that is data moves from devices and applications through a brokering unit. So why this brokering unit is kept is each data is a highly valued and an important set of source to be communicated to one platform to other platform, and in this platform we need to ensure whether all the data are projected in a unit of synchronicity or encrypted form. So for that a brokering system is needed in between to govern the master as well as slave class units. So starting with these protocols, we have certain rule sets to ensure how the data are being transferred from one form to other form, that is from device to application, because device gives a bunch of data in a serial format or in a multi split format, communicating it to the devices from communicating from the devices to application. So application always deals with application layer, where the data are being confined to a single source of outlet. So for creating such things, we need to have some idea of how these protocols are being shared. So why such protocols? Because the fundamental idea of this is no single protocol fits every situation, because every protocol has an idea of utility services in the sense it always depends upon the scenario, how the data is being pulled out from the devices and flushed out to the application layer. So a battery powered sensor, an enterprise payment, and a self-driving car all are not similar, because a battery powered sensor will give some sorts of data that is completely a data based upon the environment, and enterprise payment system, it is completely an authenticated. See, bank transfer systems are things that services that serves better, okay. While in self-driving cars, it is completely a environment ecosystem based thing, where the car's position as well as the geographical things all must be all must be connected in such a fashion that it does not create any sort of disconnectivity or discomfortness, okay. So but they differ widely in bandwidth, power, latency, and reliability needs, because sometimes the sensor creates more power to be absorbed, that is bandwidth, and power, latency, and reliability needs, that is power, latency, reliability needs, in the sense the bandwidth is observed, and power and latency and reliability needs are taken into considerations, where things moves very faster actually. So each protocol in the stack traits of simplicity, overhead, and guarantees differently, which is a real system often combined with several features over here. Say example, we start with the device constraints, network conditions, and delivery guarantees, and latency requirements. So device constraints, in the sense certain devices need to be taken into consideration to identify whether the device has battery life, memory, CPU limit, what a sensor can run actually. So the devices are very keen in identification. So the device is very keen in identification of things that are under screening mode. Then the network is connected. So device, okay. Then the network is connected. So what does the network does? The network develops a connectivity such that the losses, bandwidth, and links that are very lighter and that needs more resilient protocols or things that are more creative in the way of expression, making the network more robust. Okay, then delivery. So data are actually delivered without any loss. So the lossless delivery of data is very important. That becomes the latency, and latency develops with real-time control, that is sharply from various periodic status. That is, latency is some delay. Here delay helps the buffer, actually delay helps to create a sort of a buffer or a sort of space to be sent or to be ensured, so that it is very important, or it has very mm, a better space to bridge the differences. So all these four ideas, that is device constraints, network conditions, delivery guarantees and latency requirements, create a protocol, and the protocol is a high-end protocol or low-end protocol. But the example of this deals with experience of creating a good protocol setup. A brute protocol setup always deals with device constraints, network conditions, delivery guarantees and latency. So how these are being bridged with this 5 protocol that we use. Okay, so first is MQTT. It is the first idea is device constraint, second is network, then delivery, then latency. So here in MQTT the thing is lightweight. Actually it is lightweight in the sense it will act very fast. Publish and subscribe method, that is, once the data is established, publish is triggered, then once it is published, then subscription is triggered. So here the broker built for constrained devices in the sense it will act swiftly. Suddenly it will push out things with subscription and publication methods. Okay, then CoAP, that is RESTful protocol over UDP, that is Universal Datagram Protocol, built for low power lossless networks. So low power lossless networks in the sense basic idea of this protocol is you need to be powerless or low power, sorry, not powerless, low power. So low power must be there, latency must be very low power. Low power handling and latency handling is very important. It should have low power, and latency must also be good actually. Then AMQP, that is enterprise grade message queuing with the routing, transition and guarantees. AMQP actually is a higher end model when comparing with MQTT and CoAP, which gives a pile of transactions, mainly the bank transactions. Actually all the Google Pay, Phone Pay or anything which deals with the bank transactions all deals with these types of protocols, where internet connectivity, even though it is very low, high or it based upon the networks, the main thing is it should create some data authenticity, as well as it should avoid data loss, or it should create a bridge where the data is not actually lost, or data is not actually missed out during the transactions, because bank transactions deals with more value, and when a thing is more valuable and which is geographically present anywhere else in this world, we cannot establish a quick set of data transfer based upon the network, that is wireless network. Somewhere in a hilly station it may be differ, and somewhere in a local terrain it may differ. So things does not covers much with these areas actually. So for that we need a powerful robust data transfer as well as data guidance protocols. Then HTTP. We will discuss these things in the next video. Thank you.